An absolutely essential skill for A-level chemistry is being able to work out chemical formulae. It's really straightforward to be able to do this, and the number of mistakes, the number of marks you can lose in your exams is horrific when it's a simple thing to do, and as long as we can get this sorted now, it will make your life during A-level and beyond much easier. So let's have a look. So the first thing we're going to do is we're going to assume everything's ionic. It may seem a bit weird and it won't work for everything, but it will certainly work for the majority of compounds for the first part of your A level before you start looking in more detail at bonding and structure and where the rules break down. What we do is we look at group one and we say, okay, so all of group one, including hydrogen, they form +1 ions. So that goes there. So that's all of group one. All of group two here, they form +2. The D block elements there, they have various ions that they can form. So we're always told which ones they form. The only ones you may not be told are zinc. Zinc always forms +2, like so. And so you may not be told that one. You probably be expected to know that. And also silver there only forms silver plus ions, like so. So those two, I'd be make sure you know those two. Group three, we're going to assume form +3. Group four, we'll just say that they can either form +4 or -4, doesn't matter, but we'll just call it a 4. And then we go back group 5 -3, group 6 -2, and group 7 -1. And obviously group 0 or group 8, no bond gases do not bond, so they're 0. So we're going to assume that is how the elements react and the ions that they form, and that will allow us to work out the majority of formulae, which will make our life a lot easier. So we're going to look at polyatomic ions now. These you really need to learn. It's not too bad, but you do need to take some time to learn these. It'll make your life a lot easier in the coming months. So polyatomic ions are groups of atoms that are covalently bonded together but have an overall charge. So ammonium, for example, is a nitrogen atom combined covalently to 4 hydrogen atoms but has an overall positive charge. Now you'll notice that there are 2 types of nitrate and 2 types of sulfate. The sulfate and nitrate that you are aware of, whenever you've heard nitrate in the past, it's NO3 minus, and whenever you've heard sulfate in the past, it's SO4 2 minus. Now, when you come on to look at this in more detail, and you look at a topic called oxidation states, you'll understand why we've used those Roman numerals. So nitrate 5 is its proper name for NO3 minus, and sulfate 6 is the proper name for SO4 2 minus. Nitrate 3 and sulfate 4, you may have heard of them before, but by their old-fashioned names. Nitrate 3 is more commonly known as nitrite, and in a similar way, sulfate 4 is known as sulfite. So the ite means they still contain oxygen, but one less than the more common one. So you'll notice that nitrate 3 is NO2 minus, and nitrate 5 is NO3 minus. But you may all see them marked as nitrite and sulfite. But you do need to be aware that those are their proper names. Cyanide you may not come across is actually carbon bonded to a nitrogen atom with a minus charge. Over on the other side, these are less common, but I thought it'd be useful for you to be aware of these as well. You probably come across hydrogen carbonate and hydrogen sulfate. They're just the corresponding carbonate and sulfate with an H plus added. And then you've got 2 different types of chlorate and vanadate, manganate, chromate, and dichromate. Certainly dichromate, that one, dichromate 6, you will be coming across in the organic chemistry. But they're useful ions to know, but certainly this table is really important for you to be aware of. So let's get down to how you work out chemical formulae. So the first thing you're going to do is you're going to write out the symbols of the elements. So we're going to start with magnesium chloride, and so I've written out the two symbols Mg and Cl. And then I look at the periodic table. I remember that magnesium is in group 2 and therefore will form +2 ions, and chlorine is in group 7, so forms -1 ions. So that I've just got from my periodic table. Now I cross those two numbers over and I remove the charge because we don't need that anymore. You always do need to make sure you've combined a positive with a negative. So the Cl -1 goes over to become underneath magnesium, like so. And the magnesium +2 goes under the chlorine 2. And that is your formula, MgCl2, like so. So nice and straightforward, and it will work for all of these compounds. So this shows the simplest ratio. So in terms of magnesium to chlorine, it's a 1:2 ratio. So you can't cancel that down any further. But if we'd been looking at, say, calcium and oxygen, the charge on calcium is +2 and oxygen -2. So if you swap those over, it becomes 2 to 2. So the formula would be Ca2O2, which, this is the simplest formula we can get. So Ca2O2, you can cancel down to just be CaO, which is the formula of calcium oxide. So we're going to go through some examples now to make sure we've got the right idea. So the first one we'll do is a sodium sulfate 6. So that's the normal sulfate that we have. So the first thing we do is we write down sodium and sulfate. And the charges on those are +1 and -2. We'll swap those around and remove the charge. So that becomes 2 underneath sodium and 1 underneath sulfate. And therefore the formula is Na2SO4. Next one, calcium hydroxide. So we do exactly the same. We have got calcium and hydroxide. Hydroxide is -1, calcium is +2 because he's in group 2. Swap them around and pop them in the formula of calcium hydroxide. Obviously remembering that we need to put the hydroxide in brackets like we have here, because otherwise if we put the formula CaOH2, that would just mean I've got two hydrogens, so I need to put them in brackets to show that that too accounts for all the hydroxide. Okay, next one then. Barium sulfate 4 now. So this is Ba now SO3. Because it's sulfate 4. So put the charges +2 -2, swap them around, 2 2. So the simplest ratio is 1:1, so it's BaSO3. So let's carry on. Titanium 4 chloride. So titanium is a transition metal. So we've been told the charge on titanium, as you'll come to hear, that is called its oxidation state. So let's pop those numbers down. +4 for titanium, -1 for chlorine, because chlorine is, of course, in group 7. And therefore the formula is TiCl4. Calcium nitrate 3. So this is NO2 minus now. So we pop them in there. And calcium, of course, in group 2, so it's +2. Swap them over and gives us the formula of CnNO2, and I've got 2 of those. And then the final one is platinum 4 sulfate 4. So this is going to be, platinum is going to be in, have a charge of +4. And this is sulfate 4, so it's SO3 2 minus. Swap them around, 2 to 4. And therefore the simplest ratio is 1:2. So it's Pt, and then our sulfate 4 ion is going to be in brackets, and I need 2 of them. So when it comes to writing a formulae, it's just important to remember, particularly when we come to equations, that nitrogen and oxygen are both diatomic molecules. So they never go around as the atoms. You can never buy a cylinder of N atoms or O atoms. They always exist as N2 and O2 like so. So you must always remember to write them as N2 and O2. The same. There are some other diatomic molecules that you need to be aware of. The next one is hydrogen. So hydrogen always goes around as H2 molecules, and all the halogens here go around as diatomic molecules. So just remember it's going to be this upside down L there and hydrogen over there that you need to remember. There are a couple of others that it's quite useful for you to be aware of as well. So we have, along with the diatomic molecules, we have phosphorus and sulfur. So phosphorus goes around as P4 molecules and sulfur is S8 molecules. Now, because they're solids, it's normally fine to just use P for phosphorus and S for sulfur in equations. If they want you to use P4 and S8, they will tell you normally in the question. So on the next few slides, there are lots and lots of formulae for you to have a go at. I'd recommend you pick a few, so you can see there's quite a few of sodium, potassium, magnesium and calcium and so on. So pick a few and have a go. Just remember that wherever it says sulfate or nitrate, that's the typical nitrate. So sulfate is SO4 2- and nitrate is NO3-. And there's a few more here again. Just pick a range. Do an aluminium, a copper, a zinc, and a silver. Remember, silver is one you need to know that is going to be Ag+. Zinc you also need to know is being Zn2+. If you want to download this as a worksheet, you can do by following that link at the bottom there. A few more now involving transition metals, and then the 55 onwards has ammonium. Remember, ammonium is NH4+. So this last page is more challenging. Just have a look at the name. Remember what we've said about the names, and that will help you in terms of putting together the last few where you've got two non-metals bonded together. And the answers are on the following slides. So have a go at these, try and do as many as you can, and then we'll have a look at the answers. And again, the answers can be downloaded by following that link. So you'll get one file which will have the worksheet with the names of the compounds, and followed on will be the answers which are here. And this is the final page of answers there. So I hope you managed to have a good go at those. As I say, it's a really important skill for you to be able to do. It's absolutely key for the first part of A-level chemistry.